Okay, so part 2 of our differentiation questions. We're going to again use the chain rule because this is a function within a function. So the function inside is x plus sine 2x, and then I can rewrite the whole function as just u cubed. Both things nice and easy to differentiate. So if we differentiate this, x differentiates to 1, sine goes to cos. Remember to bring that extra factor of 2 in front, so I get 2 cos 2x. And if I differentiate this one with respect to u, I get 3u squared. In which case, dy by dx, following the chain rule, is to just multiply these two things together. So I've got 1 plus 2 cos 2x multiplied by 3. So I'm going to put that in front, and then u squared, which is x plus sine 2x all squared. Okay, there is nothing else we can do with that. That is literally going to stay as it is. Next one, again, you've got one function being multiplied by another function. So this time we're looking at the product rule. So u is x to the power of a half, v is ln 3x. That means if you differentiate this one, I'm going to get a half x to the minus a half. And if we differentiate ln 3x, we're going to get 1 over x. If you're not sure about that, again, follow the chain rule. Look back at question 3 as your example. When we differentiated ln 2x, we got 1 over x. ln 3x is also going to give you 1 over x. But that means product rule for dy by dx is v du dx. You just chuck this in front. So it's a half x to the minus a half ln 3x. Plus, and then you've got x to the half multiplied by 1 over x. Just for the sake of tidying that second bit up, remember this is x to the power of minus 1. So what you've actually got there is x to the power of a half times by x to the minus 1. When you multiply, you just add the powers. So a half take away 1 is minus a half. You get x to the minus a half. And again, you could factorise out minus x to the minus a half and leave you with a half ln 3x plus 1 if you need to do anything else with these sorts of questions afterwards. Okay, and now the next one is one function divided by another, which means it is a chain rule, and it is a horrible looking chain rule, sorry, quotient rule this time. So u is 1 minus 10x and v is 2x minus 1 to the 5. That means if you differentiate this, you just get minus 10. Differentiating this one, remember, you can either work on the side of your page, write out the chain rule, or you can remember that we did it in our head. So we bring the 5 in front, you get 5 lots of 2x minus 1 to the 4, multiplied by the differential of what's inside, which is just 2. So I end up with 10 lots of 2x minus 1 to the 4. It doesn't matter if you do this or if you have to write it out on the side, it's whichever is more useful to you. And then we're just going to use our quotient rule, and this is not going to be a pretty looking answer. So v du dx, you get minus 10 lots of 2x minus 1 to the 5 minus u dv dx, which is 1 minus 10x times by 10 lots of 2x minus 1 to the 4. Notice that I've put the 10 in front, not in between the brackets, okay? Over, and then v squared, well, that is 2x minus 1 to the power of 5 all squared. So this one's going to take a little bit of kind of manipulating what's going on. We did do some of this back at the start of the term. Multiplying the powers, you'd get 2x minus 1 to the 10 on the bottom. Right, now what you can see is this 2x minus 1 appears in every term on here. You've got 4 of them, 5 of them, 10 of them. So I can take 4 out of each of them. That would leave you with 1 there, none there, and 6 there. So I end up with, now I'm going to go on to another piece of paper. Let me just make sure I've got some actual plain paper. Okay, what you're going to end up with is minus 10 lots and 1 bracket left, minus 10 lots of 1 minus 10x. Obviously, all 4 of those have disappeared. And on the bottom, you've just got 2x minus 1 to the 6. Now, the top of that you can then expand out and make look much neater. So I get minus 20x plus 10 minus 10 plus 100x over 2x minus 1 to the 6. They're going to cancel each other out. You end up with 80x over 2x minus 1 to the power of 6. So that is obviously much nicer than leaving it in this sort of horrendous format. Just remember, all we've taken out is 4 lots of that same bracket out of every term. Right, let's see how far we can get. So if we look at question 4, you might just about get these onto this video. So for question 4, you've got y is 2x minus 3 to the 5. The point P has coordinates w minus 32. Find the value of w. Well, I know that y is minus 32, so I get minus 32 is equal to 2x minus 3 to the 5. So if you take the 5th root of both of them, you're going to get minus 2 is equal to 2x minus 3, in which case 1 is equal to 2x, so x equals a half. Okay, equation of the tangent to C at the point P, where m and c are constants. You want to leave it in this format. So that means first thing we're going to do, if we're finding equations of tangents, I need to differentiate our original function, which is 2x minus 3 to the 5. So again, bring the power in front, reduce the power by 1, and times by the differential of what's inside, you get 10 lots of 2x minus 3 to the 4. So there's my gradient function. I want this at the coordinate a half minus 32. In which case, at our point P, you get dy by dx equaling 10 lots of 2 times a half is 1 minus 3 is minus 2 to the power of 4 is going to give us 160. Yep. Okay, in which case we've got our gradient, very odd looking gradient there, and our coordinate. We're just going to find the equation of the line. Y minus 32 equals 160 of x minus a half. So you get y plus 32 is equal to 160x minus 80, in which case you get 160x minus 112, and there's my equation of my tangent. Okay, and last question. This is similar to the one that came up on the paper you had for half term. So y equals e to the 3x cos 4x. Give your answer to 4 decimal places if we're finding a turning point, which remember is just another word for a stationary point. So differentiating it, this is a product rule because it's one function times by another. So u is e to the 3x, v is cos 4x. So differentiating e to the 3x, you just bring the 3 in front, power doesn't change. And then cos goes to minus sine, but remember you bring the 4 in front, so minus 4 sine 4x. And then we're going to use our product rule. So dy by dx is v du dx, this just goes in front, 3e to the 3x cos 4x plus, but since I'm adding a negative, it's just going to become a minus 4e to the 3x sine 4x. And because we're looking for a turning point, we want this to equal 0. Now remember what we did in the test. We said that because e to the anything never equals 0, if you think about your e to the x graph. Okay, if I can factorise e to the x out, it's basically just going to disappear. So I get 3 cos 4x minus 4 sine 4x equals 0. That means if I state e to the 3x does not equal 0, then I'm just solving where this bracket equals 0. So I basically want to solve that 3 cos 4x minus 4 sine 4x equals 0. So take the sine across. The only thing I can turn sine and cos into is tan. So I want to do sine over cos. So I'm going to bring this side, this side. I get 3/4 is equal to sine 4x over cos 4x, which is tan 4x. And then if I do tan to the minus 1 of 3/4, and remember we are in radians, you get 4x is 0.6435, and it does say 4 decimal places. Okay, but remember, this is your 4x values. So your region is now 4 times this. So the region you're testing in is actually between pi and 2 pi. So you need to think about your tan graph between pi and 2 pi. So that's what your graph looks like. We're only looking within the region pi and 2 pi, and we've got a result of 0.6435. So that's that value there basically. Okay, bearing in mind that that's 3/4. So you get your result is there, and since it repeats every pi, if I just add pi to that, I get 3.7851 to 4 decimal places. And just remember, so you've got that result there, which does fall within your region. There's no other results in your region, but you do need to divide it by 4. So in our case, x is just going to equal that one divided by 4. You get 9.4. Sorry, let's try that again. 0.9463 to 4 decimal places. Okay, sorry about squishing that on the end there. But obviously, there's no point in dividing this one by 4 since it's not within the region they've asked for. And that's it for differentiation.